Hi, my name is Eric and I'm one of the co-founders of InQuery. Today we're excited to share with you guys the InQuery Trino Gateway. The InQuery Trino Gateway is an intelligent query gateway for distributed query engines like Trino and Presto for now and eventually Spark that alleviates system bottlenecks by serving as the coordinator for your engine's query traffic. Today I'll be showing you how the gateway can forecast the CPU time for incoming queries and then leverage this prediction to route those queries to the appropriate cluster, as defined by easily configurable routing rules within the gateway itself. Let's go ahead and jump into a demo. Today, I'm an analyst at a telecom company trying to put together a report to inform our CEO which geographies we should focus on for our next sales campaign. To help me with my analysis, I'll be running a simple query that tells me how many transactions occurred in each of the countries that we service. My organization has set up 2 identical Trino clusters that I can use to power my analysis, so I presume that I'll be fine to use either one. So I start by going ahead and running this simple query, which I expect to run relatively quickly, against cluster 1. If I go to the open source Trino UI, which ships with open source Trino, I can see the total query wall time for this live active query, as well as the total CPU time that this query has spent on this cluster. Here we can see that after close to 20 seconds, the query has spent 0 milliseconds worth of CPU time running in this cluster. To see more details about the query's execution and the cluster's current traffic, I can head over to the InQuery observability tool and actually see that the cluster is running close to 90% capacity right now, which will inevitably lead to some resource contention amongst queries. While that query runs, I'm going to go ahead and switch over back to Superset and connect directly to the InQuery Smart Gateway. I can run this query directly from Superset, and then I can head over to InQuery's Trino Gateway query history. Here I can see the query appear, and I can see a few pieces of metadata about this query. First, I can see which cluster it was routed to. In this case, it was cluster 2, as compared to cluster 1 where we ran our original query. I can see who sent it. I can see where it came from. I can check out the query text, and most importantly, I can see the estimated CPU time that was estimated by the gateway before routing this query. If we take a quick detour to our routing rules, we can see that I've defined a routing rule here called query size. This routing rule is enforced by the gateway and says if the query's estimated CPU time is greater than 5 minutes, we can route the query to the large query cluster, which in this case is cluster 1. Because our query was estimated to only take 15 seconds worth of CPU time, it was routed to the small query cluster, which in this case is cluster 2. What this rule does is it separates large queries from small queries, so that large queries that tend to be less time sensitive can all run in one cluster and queue up behind each other, while small queries have a faster lane for quick execution so that small queries aren't stuck competing for resources with larger queries. This is like having separate lanes in a freeway where large buses and trucks can go in one lane and smaller compact cars can zoom down another lane in an expressway so that they're not competing for space on the freeway. If we head back to Superset, we can see that this query executed in about 20 seconds when it ran against the gateway and was routed to cluster 2, while the query that we ran against the original cluster is still running at pretty close to 3 minutes. Both of these clusters are identical 20-node clusters with nodes of the same size, but the only difference was how much traffic was running in each cluster. By predicting how much CPU time and eventually how much memory each query will use and then routing it based on that information, we can make better use of the resources that we already have. As an added bonus, we can also use this prediction to proactively enforce execution limits, so that analysts no longer have to wait in order to find out their query was too large to run in a given cluster. This gives my analysts tighter feedback loops and leads to less resource waste overall. With the query gateway on my side, I can accelerate average query latency by using the resources that I've already provisioned, and since I'm making better use of existing resources, I can limit the amount of time that my clusters spend in a scaled-up state, which can help reduce overall infrastructure costs for my organization. Today, we're excited to share that we're open sourcing both the gateway with the extensions as well as the observability tool, and we'll make these publicly available for you guys on GitHub. Thanks for watching.